Okay, these are all the equations for circular motion that you'll need to memorize. I'm going to show you what each term means. So if you have a particle going in circular motion, like in this diagram here, it's going around at constant speed. Let's say, for example, let's say velocity or speed is really displacement over time, or distance over time, really. The distance here can be determined using r and theta, as long as you use theta in radians. That arc section is r theta. Okay, the s is equal to r theta, and the time it takes, let's say, is t. So that's one equation. Now we can use the circular motion for a whole one rotation. To do a one whole rotation, it will take you will be basically going around the circumference, won't you? So you'll be going around all the way around. So to figure out the circumference, you'll use 2 pi r, and the time it takes to one whole orbit, one whole circular motion, is going to be the time period, capital T. Okay, and of course, if you remember from the waves topic, 1 over f or 1 over t is equal to f, so we can just rearrange this as 2 pi r f, where I've taken the 1 over t and turned it into f. Okay, so that's for speed, and that's measured in meters per second. Okay, now the next thing is something new. This symbol here, it looks like a W, but it's actually a lowercase omega, is angular speed or angular velocity. You can use either terms for it. Okay. Now the best way to understand what this is think about its units, to memorize units. Its units is radians per second. So it's how much radians angle you cover every second. So that's why the equation is the angle in radians divided by time it takes. Okay, so the best thing is to memorize these units. When you do one whole loop, you basically do 2 pi radians, don't you? Because you go all the way around, and the time it takes to do 2 pi radians is the time period, because it's just done one whole loop. Again, using 1 over t equals capital T equals 1 over f, you can use 2 pi f. Okay, right. Now, if you look at these equations here, for V and for W, you notice that one of them has R in and the other one doesn't. So that's the only real difference between V and omega. Okay, between velocity and angular speed. So that's how you get this equation here, which you should memorize. Very useful equation. Velocity or speed is equal to angular velocity or angular frequency times the radius of orbit. Okay, and this is always toward the center of the orbit, between the center and the center of mass of the object that's doing the orbit. Okay, you know this equation. This one here, you just need to memorize. You can learn the derivation, but you don't need to. This one you need to memorize, and from this one you can get the rest. So if you have the acceleration, if you remember, the acceleration is still measured in meters per second squared. If you remember, its speed isn't changing, but its direction is changing, so its velocity is changing. So the equation is v squared over r. And if you don't want v, you want omega instead, the angular velocity, you can use, instead of using v, you use this equation and write omega r squared over r, which simplifies to omega squared r squared over r, which becomes omega squared r. Okay, and then using Newton's second law, F equals ma, we can just write this as m times v squared over r, because a is v squared over r, or we can write this as m omega squared r. Okay, so these are all the equations you definitely need to memorize for circular motion.